Okay, welcome to section 8.4. I promise I'll make this video shorter than one yesterday, and also hopefully I don't have the same hiccup that I had yesterday with my laptop. So let's just keep our fingers crossed everything comes out okay with this video. So 8.4 is not too bad. It's pretty short. It's involving multiplying and dividing rational expressions. Remember, we've already talked about what a rational expression is. It's basically a ratio of two polynomial functions. So your numerator is a polynomial function, your denominator is also a polynomial function. So in each of the four examples we do today, we will simplify. Number one is just simplifying that fraction, but number two and three involve multiplication, four involves division. And there's actually going to be some factoring involved as well. So let's just get straight to it. For number one, what I would do is factor. So if you factor the top and factor the bottom, should be pretty easy to do. The bottom becomes that. The top, if you want to do the little diamond thing, we get negative 5 and 3. Those cross off, and that's your answer. X minus 5 over x minus 3. And let me warn you, please, 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 I'm going to put this in red. Don't do this. I will be very unhappy if you do this. You have x squared minus 2x minus 15 over x squared minus 9. Don't cross off those x squares. You got to think about when you're crossing off a group of terms or one term, it's actually you're doing division. Because like here, x plus 3 over x plus 3, if you think about it, you have x minus 5 over x minus 3 times x plus 3, x plus 3. This whole thing equals 1 because you have something divided by itself. That's why we're allowed to cross it out, because we have a division. And of course, since x plus 3 is being multiplied to x minus 5 and x minus 3, and the inverse of multiplication being division, we're allowed to do that. But over here, you have x squared subtracted 2x and x squared subtracted 9. The x squares can't cancel like that because division is not the inverse of subtraction, so we cannot do that. There's no way we can sort of separate out the x squares and have it away from all the other stuff. So please, please, please do not do that. Factor it, and then you can cross off your factors, as long as they're being multiplied to all the other stuff. Okay, let's look at number two. Now for this one, we can't factor, because there's really nothing to factor here, but what we could do is combine these two fractions. So you get 56, x7, y4, just using my properties of exponents, 8x y cubed. 56 over 8 reduces 7 over 1. That reduces to x6. We have x7 over x. And that reduces just y. So nothing's left on the bottom, just a 1 up top. 7x, 6y. Very simple. There's other ways you could have done it as well, but I prefer to combine the two fractions, then cancel stuff out. Let's look at number 3. Okay, for number 3, again, we want to factor. So you can factor out 3x from the numerator of the first fraction. So that's 1 minus x. Down below, you do a diamond if you like. So 5 and negative 1. X plus 5, x minus 1. Up top, if you want to do a diamond, x plus 5, x minus 4. And here you have 3x. Before I cross stuff out, just like I did in number 2, let's combine the fractions. So that way we're less likely to make a careless mistake. So these go away, and these go away, and these actually go away too. But you gotta leave behind a negative 1. The reason why is because 1 minus x equals negative 1 times x minus 1. So if I were to rewrite 1 minus x, make it times negative 1 times x minus 1, then we're okay. So the answer would be negative of x minus 4, or you can express your answer like this. Either way, I'll accept it. Okay, and then one more. So as I promised, this is a short video. Here we're dividing. Now remember, when you're dividing fractions, it's like multiplication, but you got to take the reciprocal of what you're dividing by. So you got to flip over the fraction you're dividing by. So right now, if we see 3x squared plus 5x as what we're dividing by. If it's not a fraction, assume that one's in a numerator. Sorry, one's in a denominator, because anything divided by 1 is itself. Then we flip. So 6x squared plus x. So I'm going to flip the second fraction. Then we want to factor. So it's really number 4 is no different than something like number 2, or like number 3, actually. But just one extra step, you got to flip the second fraction. Okay. Let's take care of all the easy factoring first. So the denominator of our second fraction after we flipped it factors x times 3x plus 5. That's easy. We can't factor the denominator of the first fraction. Now, for the numerator of the first fraction, you could do the diamond if you want. But this is going to be a little bit different than all the other trinomials we factored, because the leading term has a coefficient that's not 1. So there's a few ways you could factor this, but if you think about it, the whole point of these problems is so you can simplify it, right? So things should naturally go away. So I'm going to assume that I have 3x plus 5 as my first thing I'm going to factor. That means that this has to be 2x. So what do you think the last term is going to be? If you have minus 15 and you have a positive 5, this has to be negative 3. If you check it out, if you FOIL, negative 9x, inner, positive 10x, that will get us actually plus x up here. So I know I factored this right, but if you were to actually go about it this way, I would get 10 and negative 9, but then I would have to factor by grouping. Factor out 2x, and factor out negative 3. So you could do all that work if you wanted to, but if you just use a little intuition and realize that, well, things should actually go away, and there's a 3x plus 5 in the bottom one of the fractions, probably 3x plus 5 is going to be factored out. And so that goes away, and it looks like that is it. So 2x minus 3 over 4x cubed will be my answer for this problem. So I'm all done with this video. So instead of having you do some book problems, I'm going to put a link for a Google Docs form that I'd like you to fill out. And we'll see how this goes. So I'll see you guys next time. Goodbye.